class. This is chapter 1 in Chem 103, and it is chemistry in our lives. So we need to first open up and understand exactly what chemistry is. Chemistry is, in simple terms, the study of matter or substances. What are they composed of? It's a branch of physical science, and it really gets down to studying the composition, structure, properties, and change of matter, which means that we also have to study chemicals. Chemicals are substances that have the same composition and properties wherever it is found. What that means is that water is H2O. That's the chemical composition, what makes up the chemical formula. Water, no matter where it is found in the world, if it's pure water, it is always H2O. This is a chemical. We know it as water, but it's a chemical. And that is what we'll be studying, is a lot of what makes up chemicals. For instance, another example would be sodium chloride. We're all very familiar with sodium chloride. It is, if you don't know yet, but it's NaCl. That's the chemical formula. It's used to flavor and preserve food, used to create a saline solution. Saline solutions are commonly found in eye drops, and saline solutions are also administered at hospitals through an IV when a person's dehydrated. Salt has a lot of purposes for it, but the chemical compound is always NaCl. So now that we've gotten somewhat of an introduction, chapter 1 is really just an introduction of some of the things that we'll be covering in more detail later. One of the steps that we need to cover is scientific method. Now, scientific method is a series of steps that are followed to answer specific questions being investigated. So if you want to do research on something, you need to follow a specific set of rules that all scientists cover in some way or another. This is to allow others to repeat your work, look at your data, make sure that everything is going in steps that it should. So let's understand these steps. Your book has them more condensed, but I've expanded them out to give a better understanding of what these are. So for us, we have 5: observation, question, hypothesis, results, and conclusion. So here, let's take a look at what this picture is. And the picture is that this person is going to use soil to plant a plant. And then they wonder what type of fertilizer works best. So they now are going to go in, that's the question, the hypothesis. They are going to test their theory. They're going to test, they're going to test their hypothesis. They want to see what the results would be. So plants grown with the fertilizer A will grow the fastest. That's a determination that they're going to make based on what they have in front of them to pretty much determine what the results are. They're not going to fix the results. This is going to be very as unbiased as possible, but this person has made a hypothesis that they believe fertilizer A, for whatever reason that's not written here, that may be the best one. It's usually in form of a question, but in this example, I'm giving to you just a statement. So when the results come in, everything is analyzed, including observations and data. And then from everything that they have collected, they make a conclusion up. Now, sometimes that works, sometimes that doesn't. Here's another experiment. I'll cover what doesn't in a minute. So an experiment, how do the different chemicals and fertilizers affect plant growth? So I just basically went over this. You control everything except for one variable. So you keep everything for all the plants as consistent as can be and only change one variable. And that one variable will allow you to be able to match up and look at the results as unbiased as possible. So in this case, they use different chemicals. They use different fertilizers, but let's say they use the same plant, try to get the plant with the same growth amount in the beginning. Everything was watered with the same amount. Everything got the same sun. Everything exactly to be as standardized as possible, except for whatever the dependent variable is. So here is just an overview of what I stated. Observation is the first step of method. So you observe something that might be of interest to research. Question, what have you observed? You formulate a question around your observation, something you might be interested in researching. Then the hypothesis comes in. This is the whole purpose of the experiment, an idea that suggests an explanation for the observation. And then 4, you gather your results. Report of what happened in the experiment. This includes all observations and all data. And this is usually where graphs and charts are used to basically be able to summarize everything easier. And then from all your results, you formulate a conclusion, and that is strictly based on the results. As scientists, we have to remove our bias of what we want to happen or what we think is going to happen. Yes, you make a hypothesis, but when you're looking at data alone, you take strictly the results, and that's how you formulate your conclusion from analyzing what your data has given you. So a conclusion is developed. If this hypothesis is supported, if your conclusion supports what your hypothesis was, then great. You can continue researching a little bit more into this, or go, do something else with it. But what if that doesn't happen? Then you'll have to take a step back. New testing, repeat the experiment, improve procedure. And science is always changing. There's nothing, we are still finding things that we didn't know before. So science constantly changes. And if it changes on something that you had a hypothesis supported before, you'll have to go back and repeat it again with new information to see if it still stands up. So it's very fluid. We change with whatever new information comes in. And here's just a chart to show you exactly the steps of what I basically summarized in the previous one. Okay, so I took these questions straight from your book. Let's go through, and I'm going to give you an idea of, if I ask you questions about scientific method, you should be able to understand what I'm looking for and provide the answer. So identify each as an observation O, hypothesis H, experiment E, or conclusion C. During an assessment in the emergency room, a nurse writes that the patient has a resting pulse of 30 beats per minute. So that's the one we want to focus on here. So let's highlight that one. So based on what you're stating, what we're reading here is that a nurse is observing something. So this would be an observation. There's nothing else that's been done. It's not an experiment. It's not a hypothesis. It's not a conclusion. It's just an observation. Next one. Repeated studies show that lowering sodium in the diet leads to a decrease in blood pressure. Now let's break this sentence down. Repeated studies. This means studies are experiments that have come to conclusion and there's been data. So this is basically saying that there's been conclusions with supported data that shows that lowering sodium in the diet leads to a decrease in blood pressure. So observations, experiments, everything was done and conducted. This would be a conclusion. And C, a nurse thinks that a tan incision, I missed an A there, from a recent surgery that is red and swollen is infected. So now the nurse is making an observation about something. She's looked at something and she's starting to wonder about it. This would be something questionable. So this would be a hypothesis. She could test this out some way if you sit down and try to determine what the results would be. Not everything's easy. You really have to come together to determine what you want to research and how to lay it out. But this could be a hypothesis. She's looked at an observation and she's made a hypothesis of what could be causing this problem. All right, so now we're going to get into math. This is an introductory into math. We're going to go into more math later, but this is the foundational math that we need to know. And if there's any problems with any of this, then we need to work on it together and you need to let me know. So for any number, we can identify the place value for each of the digits in that number. The place values for two numbers are listed below. Why do we need to know the place values? Because we're going to start doing conversions. We're going to start doing rounding with sig figs, and you need to know the place setting for numbers. If you don't know this, you could easily mess up and work through a very hard calculation and then get confused on the place value, and then your whole thing's wrong, or at least the answer's wrong. You should get credit for other parts of it. But this is where these small little mistakes can cost a lot. So let's take a look at this first one. A premature baby has a mass of 2,518 grams. So let's take a look at the place value. There's no decimal, and this is a positive number. So that means that the 8 is in the ones, the 1 is in the tens, the 5 is in the hundreds, and the 2 is in the thousands. So now let's go to the next one. A silver coin has a mass of 6.407 grams. This one, unlike this one, has a decimal point. So now we were dealing with numbers on this side that are actually less than 1. So we need to be able to determine place values for this that has no decimals and place value for numbers that have decimals. And we use a lot of numbers that are on the other side of the decimal. So the 6 is in the ones place, and then we have a decimal, and the decimal defines what's on this side and what's on this side. So this is tenths, this is hundredths, and this is thousandths. Now the difference, notice there's a THS. This THS indicates that these are in decimal form. They are on the right side of the decimal, but they are actually not more than 1. They're less than 1. If I'm trying to understand, is that this is a decimal point. Anything that would be 1 would be in this place. These are less than 1, these values. So here I also have another example. So anything here with a decimal point, this is ones, tens, hundreds, thousands, 10,000, 100,000s, millions. Decimal point on this side, tenths, hundreds, thousands. So if we look at this first number, we don't need to pay attention to this portion. I'm more interested in what's a decimal. This number ends in the tenths place. So if I was to give you a number and I should ask you what's in the hundreds, what's in the tenths, what's in the hundreds, you should be comfortable with knowing that information. Now the bottom one, we have 2 digits on the other side, the left side of the decimal. I'm getting confused here. The left side of the decimal, so we have 1 in ones and tens. And then on the right side of the decimal, we have tenths, hundreds, and thousands. This number ends in the thousands. Okay, and we're going to expand on the math. Like I said, this is very introductory. We are going to go more into this. I'm going to help by office hours having student sessions where we will work on numbers and problems together. This will be a voluntary meeting, but these meetings are very, very, very beneficial to help you pass this class. So positive and negative numbers. A positive number is any number that is greater than 0 and has a positive sign. Often the positive sign is not written. So either you could see something as a +4 or just a 4. And when you don't see anything with it, this is the default for a positive number. A negative number is any number that is less than 0 and is written with a negative sign. So if the value is negative, it should always have a sign to indicate it is negative. The default for positive is always just no sign because that is the default for writing numbers. If you see a number and there's nothing in front of it, you know that that's positive. So if you have something a value that is negative, you have to have a negative sign in front of it. In some cases, you'll see it as a negative sign just like this, or you'll have a parenthesis around it to isolate just that number. So you know that that number is the negative number, especially when we're doing calculations. So now we're going to do a little bit of math with this. When 2 positive numbers or 2 negative numbers are multiplied or divided, the answer is positive. So if you see here, we have 2 times 3. These are both positive. The outcome is 6. So we would write either a +6 or just a 6. And honestly, just write 6. You don't need to do the plus. It's not going to be marked wrong, but we will use plus and minus later. So you don't need to do it now. Now, if we have 2 negative numbers, they end up producing a positive. So if we have -2, and here's the parentheses, times -2, these 2 negatives cancel out, and we have a +6. Now, if we look at division, we have 6 and 3. So we divide into 6 by 3, and we produce 2. These are all positive numbers, so it should produce a positive number. Now we have a 6, nothing's changed. We have a 6 on top, 3 on the bottom, but these both have a negative sign in front of them. That will cancel out. The value should still be 2. However, the negative numbers cancel out. When a positive number, and a negative number are multiplied or divided, the answer is negative. So here we are repeating the same problems, but one is positive and one is negative. So we have 2 times -3. The negative sign does not cancel out, so our answer is -6. In this case, you will write a negative in front of the 6. Here we have -2 times +6, And again, our number is -6 because the negative sign does not cancel out because there's only one. Same thing here. We have a -3 and we're dividing into 6. The value is -2. The negative sign does not cancel out, and the same goes for this last one. So, excuse me, now let's go into adding and subtracting. When two positive numbers are added, the answer is positive. So 3 plus 4, nothing in front of them. This plus sign is just part of the addition problem. It's 7. There's no plus sign. We look at this and we know that this is all positive values. When two negative numbers are added, the answer is negative. So if we look here, we have a -3 plus a -3. That equals -7. We'll get a little bit more and expand on that. You do not need to actually write it this way, but for clarification, if this confuses you, you should take these steps to make sure you understand you're dealing with negative numbers. 3, when a positive number and a negative number are added, the smaller number is subtracted from the larger number, and the result has the same sign as the larger number. So for instance, we look at these numbers. One is positive, one is negative. The larger of the two is going to be the one that has the sign in the answer. So we have a positive 12, well, we have a -15. -15 is a larger value than the positive 12. So instantly this tells me that whatever my number is going to have a negative number with it. And this, in this case, it's -3. So here is some differences in subtraction when you're dealing with negative and positive numbers. And you need to make sure you fully understand just the general setup of these to make sure you get the correct answer. So for A, we have 12 minus a positive 5. Now, you don't need to write the positive sign and you don't need the parentheses here. So we're going to remove these because it's a positive sign. It's still going to end up being 12 minus 5 because the sign is not going to go anywhere here. So it doesn't matter if we leave this or not. This would still end up being 7. B, we have 12 minus -5. Now, two negatives next to each other produces a positive. So in this case, this is 12 plus 5, which equals 17. C, we have a -12 minus a -5. Now we have a one negative number, but we're going to end up with the same positive number we took from B. So this is -12 plus 5, and this equals -7. And D is -12 minus plus 5. So the difference between this top one and this one here is this was not a negative number. Now we're dealing with a negative number here, and this, once this removes, even though it is positive, it is -12 minus 5. So basically, in a sense, we're adding a negative, and that equals -17. One thing we absolutely use in chemistry is a calculator, a non-graphing calculator, scientific calculator. You can buy one probably at Rite Aid or Walmart for $10, somewhere around there. If you have questions, you can always send me an email at posting whatever is you're interested in, and I can help make that determination as best as I can. I'm not fantastic with calculators. I buy the same calculators over and over again, which is a Casio. The one I use more than anything is a Casio FX-300ES. I think it cost me $10 to use. I tend to use this one. I'm more comfortable because all calculators are just a little bit different with different brands. So this is the one that I know. Anyways, you need to make sure you're very comfortable using your calculator. Chapter 1 should definitely set you up for that. If you need help with your calculator, you need to let me know. You are responsible for addressing whatever issues you have as soon as possible, because once an assignment is due, I don't want to say disregard, but you basically would get a 0 because we have a couple of weeks before assignments start coming out. And once they do, or at least 2 weeks, by then you should definitely have reached out to me. So reaching out at the last minute is not going to help you. It will be a 0 because you are responsible for reaching out to me in order for me to help you. I have a lot of students. I do my best to help, but you need to let me know that there's something going wrong with your calculator so we can sit down through a Zoom meeting and try to figure out what it is. So here are some problems. addition and subtraction. These are some problems to help you make sure that you understand how to use your calculator. Now, we do normally have orders of operation, but we're not going to do that here. The book has it set up where you just work these straight through and see if you get the number. So don't worry about multiplication over addition and division and this and that. Just go through it exactly as they have it written in the bottom part here and see if you end up with the same numbers. If you do, then that means that you have a good understanding of your calculator, even if you don't think you do. You're understanding the operations buttons that you need to use in order to use it successfully. If it's not working, this is the point you would need to contact me so we can start seeing what we need to do to help you. All right, so now we're going to go into percentages. We will do a lot of percentages. They will come up later, and you need to have a foundational understanding of percentage. So this is a brief overview of percentage. Like I said, we're going to work on some problems with percentage, so this will not be the last time you see it, and hopefully as we start working on problems, it will make more sense. A percentage is a number or ratio that represents a fraction of 100. It's very important to understand percentages. I do a lot of shopping, or I used to. And sometimes I need to know how much something is off because I need to know if it's a good sale or not. So I have a calculator. I carry a calculator with me, even though I know the phone has one. And if something is 25% off and it's something I've been wanting for a while, I try to do the math to figure it out. So understanding percentage is really a good thing. It absolutely is. All right, so percentage is out of 100. So when you see a percent sign, the sign itself, that means it's out of 100. The problem may not be, but when you get it to the percent form, it's out of 100. When a value is described as percentage, it represents a portion of 100 of those items. So we're talking about when you see the sign. So think of this as a pie, and if you want to know what percentage of a slice was, that's going to be on top. So the bottom is always the whole portion of the whole thing, the total of whatever it is you're looking at. And the part is the section, whatever it is that you're looking at. So let's say for the whole, you have to add all these up. That's going to be the whole, the total. But now you want to know what blue is. So you'll have a number and you'll set that on top and then multiply by 100. And that's going to give you your percentage. Sorry, I messed up. This should actually have a times 100 here. I'll have to make a note of that on Canvas. So, excuse me. So here, divide the parts or portion by the total and multiply by 100. So here we go. Here's some examples to help you understand. You have 32 books and 8 are chemistry books. What is the percentage that makes up the chemistry books? So we want to know out of the whole 32 books, what is the percentage that are strictly chemistry books? So you need to learn how to pull out the information. So first, make sure you understand what a part is on top, whole is on the bottom, and it's times by 100. So 8 is the portion of the total, and 32 is the total itself. So you would set up the portion on top, the total on the bottom, and then times it by 100. This tells me that out of 32 books, 25% are chemistry books. Now, second problem. If you have 100 balls and you notice that 5 of them are red, what would the percentage of the red balls be? So make sure you understand what the portion is and what the total is. And sometimes they can be a little tricky in defining this stuff. But we'll cover some problems and help you understand this better. If the percentage of red balls is 5, it means that there are 5 red balls in every 100 balls. When you get into percent, that's what it means, even if it's not necessarily that way with the problem. So here we have 5. In this case, it is 100 balls. So 5 over 100, and we times that by 100, and that is 5% red balls. All right, so now we get into solving equations. We will be using x in this class to solve for numbers that we do not know. But you need to be very comfortable for solving a variable. X tends to be the variable that is used, but you can use pretty much anything. But you need to understand the foundational part of doing this. So this is a simple equation, but you should be able to understand the steps of this. If not, then you definitely need to go back and do more problems. There are problems in the back of the book that will definitely help you, or the sample problems, in order to understand how to do this. So we have 2x plus 8 equals 14. First step you do is you you separate everything into what it is and what it isn't. So what do I mean by that? Well, 2x has a variable. You cannot just subtract 2x or add 2x plus 8. This doesn't have a variable with it. So you'll have to, the best thing to do is remove this 8 and put it on this side. And the way you do that is you subtract 8 from both sides. So I'm going to subtract 8 on this side, and I'm going to subtract 8 on this side. So thereby I remove 8 from this side of the equal sign, and now it's on this side. And now I can do math on the 14 minus 8. So I have 2x, and now I have a 6. The next thing I need to do is I still have a coefficient in front, this number in front of the x, and I want to get it out away from the x. When you're adding and subtracting, you do the opposite of whatever the sign is. But when it's right next to it, you actually have to divide it. Because what this is 2 times x. But now we need to do the opposite, which is dividing. So now you also divide by both sides. So we divide by 2 here, and we divide by 2 here. This actually answers our problem. X equals 3. Now, if you wanted to check your answer and make sure it's correct, you would take this x equals 3 and plug it in to see if that works. So we plug it in, and we have 2 times 3 plus x equals 6 plus 8. 6 plus 8 equals 14. That is correct. So we did this right. All right, now we're moving on to scientific notation. Scientific notation is a way of writing very large or very small numbers. A number is written in a scientific notation when a number between 1 and 10 is multiplied between 1 and 10 is multiplied by a power of 10. Scientific notation has 2 parts. We have a coefficient and we have a power of 10. So I want to break this down. The number that's here is between 1 and 10, and then we have the base of 10, and then we have an integer. Why do we do that? Because if we look at this problem here, people have an average of 1 times 10 to the 5th power hairs on the scalp. You would rather write it like this than like this. And when we start dealing with really large numbers, say 36, you would have a whole bunch of zeros. That really doesn't work in this environment, so we have to use scientific notation. And you would need to convert if you're also already working with other numbers in scientific notation. So this is a little blurry. I got this off another somebody else posted. But why do we use scientific notation? Because we deal with really large numbers or really small numbers, and it really just doesn't work, and you're opening yourself up to more mistakes. So here, volume of gasoline used in the United States each year. You don't want to write this over and over and over again when you're working on a problem. None of these. You don't want to work on any of this. So you keep it in scientific notation, and you do your math in scientific notation, your calculations. So would you rather write this or 5.5 times 10 to the 11th power liters, or 1 times 10 to the negative 19 kilograms? This is much easier to deal with when you understand it than writing like this. So here is a rules to convert to scientific notation. Move the decimal point until there is 1 digit to the left of the decimal point. This applies for both. So what am I trying to say? We'll jump ahead here. You see that there's 1 digit to the left of the decimal sign. 1 digit to the left of the decimal sign. We don't care right now at this moment. We haven't covered sig fig rules. But we always want 1 digit in front of the decimal sign. And that's how we set it up. And it's not meant to be a 0. It's meant to be between 1 and 10. So basically 1 through 9. So how do we do this? You need to understand what you're looking at. First of all, here is a positive number. It is the decimal points here. Everything's on the left side. It is more than 1. So the exponent here is going to be a positive number. Over here, we have a number that is less than 1. The decimal point here is here, and the values are all on the right side. That means that when you are done with this, you need to make sure that your exponent is negative. If there is a negative exponent, it means that the value is less than 1, and if it's positive, the value is more than 1. So you take the number you're given, and you simply count. So I'm going to take, if there was no decimal point, you would put 1 there, and you pretty much count 1, 2, 3, 4, 5. The steps that you take equals the number that's going to go up there. So I took 5, so I would write 1.56 times 10 to the 5. In this case, we're getting rid of these zeros. We're going to cover sig figs, but the zeros still exist. We just have put them in an exponent form. If you write this out, which you'll see in a couple slides, then they're still there. We didn't get rid of it. The place value did not go anywhere. So if you look at this ones, tens, hundreds, and so forth, we didn't knock them out and make this 1.56. This number is still 156,000. That's where the place values come from. We need to make sure that we didn't just change a number and then call it equal. These numbers, if you remove the 10 times 10 to the 5, they're not equal. You need this 10 times 10 to the 5 to make these two values equal. Same thing here. If we remove this part, this value would be 5.3. That's a positive above 1. We're dealing with a number that is below 1. So you need to make sure you understand place values here too. We can't just lose zeros. That's not something. They have to all be accounted for. This number has a certain amount of place value settings, and we need to be able to understand where that number actually is if we have to write it out again. So here we do the same thing. We want it, the decimal point, with a digit in front of the decimal point. So we take this and 1, 2, 3, 4, 5, 6. Now this is below 1, so it's going to be a negative 6. However many times you have to move the decimal point, that's what the number is going to be here. So whichever way you look at it, just make sure that if it's a positive value, make a mental note that's going to be a positive number. If it's less than 1, it's going to be a negative value. And then you count the decimal point to determine how many steps the decimal point has to move. That's the number that's going to go there. So here's some examples for you. We have 52,314, but we want to follow the rules of scientific notation. We want one digit to the left of the decimal point. So we're going to count 1, 2, 3, 4. I'm moving the decimal point 4 places. I have to account for that, and this is a positive number. Here's one that is tricky, but it does exist. And if you're using other calculations in exponent, sometimes you have to change these numbers to exponent too, even if it just means 1. So when we're moving decimal points, this number is how many decimal points, how many times that decimal point was moved. Now, we don't move the decimal point here. This is exactly in the format we want. So, but we still need to put in scientific notation, say if we're using other scientific numbers. We put a times, a 10, and a 0. This really means 10 to the 0 power is 1. We never changed the decimal point anywhere. This was already set, but we still have to put in scientific notation. Make sure you're very familiar with 10 to the 0 power. That means 1. So this basically is 3 times 2 times 10, 3 times 2 times 1. Now we have a number that is smaller than 1. So this is going to be a negative exponent. And we're going to move the decimal 1, 2, 3, 4, 5 places. So make sure you set it up in the correct format, a digit in front, and then 5 places. And here we have a large number that is not less than 1, and we need to put the decimal point right here. So let's move it. 1, 2, 3, 4, 5, 6, 7, 8. We are moving it 8 places. We are dropping these zeros. They still are part of our answer, but we have moved them now into the form of an exponent. And now it's 6.02 times 10 to the 8th power. Here is powers of 10, so you understand what is happening if you had to look at the multiples. So when we're looking at something that's below 1, it's actually 1 over 10, and then we can divide it. That's what this one means. If you have 3, this is the hundredths place. That's 2. 2 multiplied by each other. You can see 1 over 10 times 1 over 10 equals 1 over 100. That's going to give you this amount here. If you do this on a calculator, this is what's going to show up. Not this, but gives you a visual of what you're seeing happening. Same thing down here. If you have 1 times 10 to the 4, that's 10 times 10 times 10 times 10. So this gives you an idea of what you're actually seeing that the calculator isn't going to show you. All right, so now again, We are going to use our calculator every class. You're not going to get out of using your calculator. You need to make sure you understand how to use it. Every calculator is different. I require that you understand how to use your calculator. You cannot come to me right before an assignment's due and say, oops, it doesn't work, unfortunately. I understand that being online is difficult, but in order for you to successfully pass this course, you have to take some responsibility and you have to inform me when there's some issues, and they have to be in well enough time that a decision can be made to figure out how to help you. Anything brought to me in the last minute does not pass. So numbers in scientific notation can be entered into a calculator using the exponent key, the EE key, or times 10 to the 10x. What does that mean? If you have a calculator, look to see what exactly you have. Some calculators have this, some calculators have an EE button. My calculator shows this. So you need to know what you're dealing with. So here is some problems that I ask everybody to do, and make sure that this is how you get it and what it reads like. You need to know not just how to plug it in to your calculator, how to read the answer as well. You're going to need to be able to pull that off and write it out if we're doing calculations. And sometimes if you don't know how you write it, then you're not going to know how to read it as well. So these are steps I require. So 4 times 10 to the 6, how do you enter that? Well, depending on what you have, it's a 4. And then you plug in the key, the button, which one you have for exponents, and then 6. And now you need to know which one you have to read, and you need to know how to read it. So this is where it's very important in the first chapter that you get this covered so we can take a look and determine what it is that you're doing. I'm not the most savviest with calculators, but usually I have some students that can figure things out. All right, same thing here. Now we have a negative. So it's 2.5. You push that button. And sometimes you have a negative button, positive and negative. That's what this means. Make sure you know how to use as well. Sometimes you'll just have a button that just has a negative sign. It's not a subtraction sign. It's different. It's separate from that. It's usually just a parentheses with a negative. My calculator has that. It has a parentheses with a negative number. And it's not the subtraction number. We don't use that number. That's different. And now you need to also make sure that you can read it out here, because if you have to pull these numbers out and write them out, you need to make sure that how to do that. So I ask everybody, do this page and make sure, as well as that other slide, and make sure you get these answers. If you don't, you need to contact me. We need to work on this. Scientific notation. So now we're going to write out scientific notation. Let's take a look at the steps. Move the decimal point to obtain a coefficient that is at least 1, but less than 10. Express the number as the places. Express the number of places moved as a power of 10. Write the product of the coefficient multiplied by the power of 10. So let's take a look at this one and break it down. So this is a positive number. It's not less than 1. So my exponent immediately is going to be a positive number. So let's look at what it is. Move the decimal point to obtain a coefficient that is at least 1, but less than 10. So let's move that. 1, 2, 3, 4. I moved my decimal point 4 places. So I'm going to set up my 6.4, and I'm going to set up my 10, and I'm going to add the 4. So basically, you're always going to have this portion, this times 10, and then you're going to plug in whatever's in front of the multiplication sign, and you're going to plug in an integer above the 10. So 1, 2, 3, 4. I wrote 6.4 times 10 to the 4, and that is correct. Now let's do the same steps for something that is less than 10. So here we have a number that is in the tenths, hundredths, thousandths place, and we need to be able to accommodate for that, or show that that's what we're dealing with. Same thing. So we are going to now move this decimal point. I lost my mouse. So 1, 2. We're moving it 2 places. But again, this is a negative number. I mean, a smaller than 1. So we have to indicate that. So I have my coefficient in 2.1, exactly how it should be in scientific notation. I write out my multiplication sign, 10, and the steps that it took me to move the decimal point, which is -2. Now, what if we wanted to move it out of scientific notation? You do just the opposite. So here we have 3.25 times 10 to the 9, but we want it in decimal notation, meaning just the numbers that we work with decimal point. You just do the opposite. So sometimes you'll have a lot of zeros, sometimes you won't have any at all. I usually just write this out and then I do this little wave thing and then I come back and fill in the zeros. So here we've got to make this number bigger. So you see that this is a 9, this is a positive number, and that's a 9. That doesn't mean 9 zeros, it means 9 movements of the decimal place. So you're going to have a very big number with a lot of zeros. So you should start looking at the overall of this and get an idea of what the number should look like. So here we have it set up 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I would do these little waves and then I would go in where the bottom of the curve is and just put a 0 there. And that will give us the number that we want. So remember when I said that we don't lose the zeros. In scientific notation, we are pretty much putting them in the exponent, but they still exist. So if we need to convert these out of scientific notation, we have to make sure they are still in the right place value in the number setting. Now we have a negative number. So here we have a 4. This one doesn't have anything with it, but that's okay. We have a 4 times 10 to the negative 7. Instantly you should notice is a negative number. So that means that this is actually not positive. It's going to be less than 1. It's going to be on the other right side of the decimal point. So here we're going to move it 7 times. So we need to put a decimal point out. So what we're going to do is, again, I don't have zeros in front of this. I have imaginary zeros. I do these little lines and then I plug the zeros in. So we follow how many this states. I add a decimal point here, which wasn't here, so you're going to add 1, and now move 7 times. 1, 2, 3, 4, 5, 6, 7. And once you do that, now I'll come in and fill all the zeros. One thing that I look at, and I will stress over and over in this class, if you're going to do chemistry, you need to be able to write things correctly. If you leave a decimal point, you must always put a 0 in the ones place. This is kind of etiquette. It's proper. A lot of students will just add a decimal point and a bunch of zeros and leave this blank. That's not correct, and I will definitely stress that in this class. If you have a decimal point, you add a 0 in front. You never leave it without a 0 in the ones standing. I'm adding this. This is kind of busy. I found this online, but most of these make sense as we start doing problems, but the ones that students tend to have a problem with are the easiest ones. The 10 to the 0 equals 1. A 10 to the 1 equals 10. So that's why I'm including this, because you may get problems with this and you need to make sure you understand this. Again, I found this online. If you have a decimal, if you're given a 2 and it's in decimal notation, but I ask you to put it in scientific notation, how do you do that? Well, you didn't move a decimal point anywhere. So you have to make sure that you are showing that. Remember that 10 to the 0 equals 1. That's all you're showing. You're moving this to scientific notation, but you're not doing anything different. So you have to be able to be very comfortable using this 10 to the 0, 10 to the 0 base. 10 to the 0. Let's just leave it at that. I'm now confusing myself with talking. So here is just some examples. And now that you know what they are on scientific and decimal, this would be a good way for you to try to follow these to get one out of decimal into scientific or scientific into decimal and test them out. And that is it. We are done with lecture for chapter 1, and chapter 2 will be coming up shortly.